Hey guys, Mr. B here again, bringing you another lovely math video. This one, just a couple of extra examples using synthetic division, if I can say that. So yeah, I have another video on synthetic division if you want something a little bit more detail. But this is just a couple of quick examples. So we use synthetic division for dividing polynomials, and that has various applications such as rational roots theorem, the integral zero theorem. You can use it for finding oblique asymptotes. But really, the most important thing you have to keep in mind, we only use synthetic division when we have a linear binomial. We're dividing by a linear binomial. So x minus 2, 2x plus 3, whatever it might be. We have to keep that in mind. Alright, so let's give this a shot. So remember, we look to what we're dividing by, and we're going to take the opposite of the number that we have. So it's subtract 5, so we're going to have positive 5. We want to make 0, so 5 minus 5 is 0. So that's what we're going to use. Then we're going to use the coefficients of our numerator, so our cubic here. So 1, 3, 4, 3. And below the last number, we're going to put a little box where our remainder is going to go. And we always got to check to make sure we have successive powers. So x cubed, x squared, x, and then nothing. So we're good to go. Alright, so let's do this. We take our 1 down. So our 1 goes there. And we multiply 5 times 1. So that gives us 5. And that's going to go right here. Then we're going to add these two guys together. So plus 5. 3 plus 5 is 8. Then we're going to multiply again. 5 times 8 is 40, so the 40 is going to go here. Then we're going to add again. 4 plus 40 is 44. Then we're going to multiply one more time, and we'll try the arrows, it's getting a little messy. 5 times 44 is 220. And then 3 plus 220 is 223. So there we go. So when we divide x cubed plus 3x squared plus 4x plus 3 by x minus 5, we get x squared plus 8x plus 44. So it always drops one power. So it's a cube, now it's squared. And we're left with the remainder of 223. One way we can check to make sure that we have this done correctly is we can actually evaluate our cubic, this guy right here, for x is equal to 5. So if we go p of 5, and we just sub in, 5 cubed plus 3 times 5 squared, so on and so forth, we should get 223. And that's called the remainder theorem. So if we don't get 223, we know we've done something incorrect. So we want to keep that in mind. Alright, let's give the next one a try. So again, let's set up our little synthetic division. So this time we have a plus 2, so take the opposite of that, negative 2. And again, we just double check, negative 2 plus 2, 0, we're good to go. And we want to start in with our numbers. So our first number, x to the 4, so it's a 7. Now we're looking for an x cubed next. We notice that we got to go successive powers. That's not there, so we're going to put a 0. If we run into that, we have to make sure we put 0 in, otherwise we're going to get it incorrect. Then we have a 2, so I'll put 2 in. Then there's no x term, so I'll just put a 0, and then a negative 3. And then below my last number, I put a little box. So again, take down my 7. Negative 2 times 7, negative 14. 0 plus negative 14 is negative 14. 2 times negative 14 is 28. 2 plus 28 is 30. 2 times negative 30 is negative 60. 0 plus negative 60 is still negative 60. And 2 times negative 2 times negative 60 is 120. Negative 3 plus 120, 117. So there we go. So when we divide 7x to the 4 plus 2x squared minus 3 by x plus 2, we can write it like this. 7x cubed minus 14x squared plus 30x minus 60 with the remainder of 117. So you want to always keep in mind that we started with a quartic, I don't know if I call it cubic for a quartic, and then it drops to a cubic, so went to a power 4 down to a power 3. So that's a quick little video, guys. I hope it gives you a good little explanation. And if you got any questions, feel free to contact me. I'll see some of you guys in class. And good luck.